you can see. Oy, it's maybe too fast, I don't think, or it can't be too easy either. Alright, welcome to this tutorial. This is part 2 of the Big Boss tutorial, and we will continue the project where we had it the last time. I have did some additions between this video. I have placed all the missing platforms. In the last video we did only this leftmost platform over here, but now we have every platform visible, and I have also changed the code so that all the values are now in hex, so it's a little bit better and more consistent code. Also, I was thinking that if you want to follow this tutorial exact, I can put a link in the description where you can download all these graphics if you want to use. I don't claim any ownership of the graphics. You know, this is made by AI, so I believe I don't even own the rights for the image. So you may use them as you wish if you want to use them in your test or even in your game. It's okay to me, no problem. Alright, so the first thing what we are going to achieve in this second tutorial is to make all the enemies fall down. As if you can remember, we had these enemies, this spiky ball and those umbrella cats, and we were showing and hiding them by showing and hiding the corresponding pallets. But maybe we could make them fall down and build a system where this happens automatically. They just appear and fall, and then the next one comes, and maybe add some R&D to this effect so that player wouldn't know which enemy will be the next one that he needs to dodge. Okay, at first we will need a couple variables. Let's put them over here. We are going to use make up some kind of phase system, so we need some kind of counter for it. Let's call it phase counter, and that keeps the tracks of the phases where we are currently in the screen. So phases are like is there something dropping or is there not, or which one of these is dropping. So we keep track of it in this variable. We also need some kind of timer if we are going to pull some timed events. Let's name this boss timer, and I believe this is good for now. Both can be 0. Yes, and then we're going to implement it in this code. At first, I think it might be easier to make this subroutine. We call it update enemy, and one trick to do with NES is if you don't want your animations to play so quickly, you can do this kind of trick to have a little wait time. There's always this variable called vblank timer that runs from 0 to FF in hex and repeats again from 0 to FF. and you can make an AND operation over here, and let's say compare it to 2, and if that is okay, we just let's make another place to wait. We blank. So basically what this does, it checks the vBlank timer variable, which increases all the time, and if it's a number that is divided by 2, it goes further. Otherwise it jumps to wait vBlank over here, and then we can return from subroutine 2. Actually we need another variable. We need to keep track of the animation frame too. So let's go to here and add a variable and call it animation frame, like this. Then we need to make our animation at this time is it's only something falling down from the top of the screen. So I have checked these numbers already, but these may differ a little bit from your project. Let's make a table, lookup table for these Y values. This is starts at 90, and we decrease the value every time by some numbers. It's all also nice to have some kind of notch in these values. So it first of all it goes a little bit down, and then it goes back, and then it comes the final drop. Okay, maybe I'll fast forward this. Okay, and now we have our move path over here, and we can go further in the code. We were in the state of showing the enemy. We need to load the current animation frame. This keeps the track of the animation where we are currently. It starts at 0, of course. This is 0, and then we load from move path the value 0 and store it to cam Y, which moves the camera on screen from up to down, and vice versa. Then we also have to increase the animation frame so we can get the next number out of this. Alright, so now we have some kind of system over here, but it isn't actually doing anything. It's only a subroutine which has to be called from somewhere. Maybe we can just call it in here. Jump to subroutine, update enemy, and let's check what this whole thing does. Alright, as you can see, it goes a bit wild there, but that's okay for now, because we don't have the values for the rest of the animation. Check. Frame. Why can't I find these? Animation frame. Over here. And this, here we can see what happens. As you can remember, our animation starts at 0. So if we put 0 over here, animation frame, so the animation it does a little bounce over there, and then it drops, and it's like 1D. That's the last value, and after that there's just some garbage which is in memory, and it does some funky things over there. But it's working as it should at this point. So instead of just calling this update enemy, we can do some kind of system that randomly puts some enemy on screen. At first we need to load the phase counter, and usually it's 0 at first, so we compare it to 0, and if it's not equal, not equal, we skip over this, but if it is equal, we then increase boss timer. This is for making phases, so each phase doesn't appear right after another. It has some break between the phase, and it goes only after a certain amount of time it goes to the next phase. So we increase the timer. It was 0 in the beginning also, and then we load the boss timer and we compare it to, let's say, maybe 50, and do another branch for this. And then if it is 50, we can increase the phase counter and just reset the boss timer. This is really not doing anything but waiting for 50 frames, and then if we have waited for 50 frames, we load phase counter again and compare it to 1. Remember, we added it to 1 after 50 frames, and then it's also quite similar bunch of code over here. And then if the phase counter is 1, we jump to subroutine update enemy, and also we check if the cam Y is 0, and if it is, we can increase phase counter and pretty much reset all the other things. You know, there is probably a million of ways to do this thing, but this is the way I have done it. I don't claim it to be the best way, but it's working. And usually when I'm making some kind of boss screen or something, I use this kind of phase counters and some kind of values that go through the boss counter. And then we need to remove this so it doesn't happen anymore. So let's go and check it check how this thing works. At first it should check the counter. If the counter is 0, it should wait for 50 frames, and after these 50 frames it should drop the enemy. If I put this as 0, it falls down. Let's do the fade in, fade out now. This is done by chasing the pallets, and as you can see, NES pallets are laid out pretty nice way. So if this pallet is 28 and this is 38, you can see they are always placed in a certain manner that if you decrease the value by 10 hex, it always gets a darker shade. That's not the case every time. Sometime it doesn't get darker, but most of the cases it will get darker. I'm going to leave it as it is because it's no point of making this more complicated, and it actually adds a nice flash effect for the fade, and that could be something you may wish to have in your game too. So pallets live in bank number 16, as seen here. Banks 16. Here are all the pallets. The easiest way is to place the code inside the do load background pallets script, and since it's already in bank 16, we don't have to care about switching the banks. Okay, so let's copy all this and make our own subroutine after this one. We can call it for reveal enemy over here, and this takes Y value, that is the current location of the pallet we would like to say. Currently it's number 1. We can do this same trick as we did before to have a little slowdown for the animation, fade in animation. We can load in vblank timer, and sometimes it's easier to figure out if you use the bit format. So each time these bits are 1, this will happen. Branch equal, and each time these are 1. So if you add to this number, of course, if these are 1, this will become 1 like this, and these will become 0. So it waits for another round that every time these 3 bits are 1, it will go forward. Otherwise, if these 3 bits are something else, so it will return from subroutine. Actually, we might need to copy these as well, because we are manipulating the Y value, so it wouldn't mess anything. Put it over here. And this is basically taking the X and Y values and pushing them to the stack, so they are there safe in some kind of safe place. So if you alter the values, you don't mess any other code. And then, of course, after we are ready, we need to pull them from the stack and place them accordingly. Okay, so we just put 1 over here, and this is the game. This is the palette we are reading, we store it this kind of temp16 variable, and then we read another. This is a 16-bit number, so we need another high byte number and store it to next value. I'm not sure if temp16 shows over here. I can show what I mean. Temp16, yes, it's over here. So it's basically these two things that are changing. This is temp16 and this is temp16 plus 1. We need 16 bits of data for the pallets. Okay. And then we need some kind of loop. And inside the loop we will load the first background palette and compare it to this temp value, and if it is branch, if it is bigger we go over there, and if it is not, then we load the current background pal. Always has to clear the carry if we are adding something, and we add number 10. As I previously talked about, the pallets are 10 hex from each other, and then we store it into background palette Y, and then we have to do another trick. Maybe we can just jump. So this is this is quite messy loop, but it's like if we have been over here, so we don't need to jump over these next lines. But if we have done it like this, we have to store this. Y. All right, and then we need some kind of way to get out of the loop. So we increase the Y every time we get here, and compare Y to hex then, and if it's not hex, then we go back to loop. And this is the code there was earlier. So basically this goes through all the pallets and checks if they need to be set the color to. It compares to the palette we have chosen to be here, and if it's not, actually I can show them all. Main. It compares it to this, and if it's not, it will gradually increase the number. This was not so good example. If it's 0, it's at 8, then 18, then it's 28. Okay. And then we need to update the screen data. One is for pallets, so we only need to update the palette data. We don't need any tile data, for example. And then we have to return from subroutine. Okay, so this was for the revealing the enemy. Then instead just updating the enemy, we will also reveal the enemy like this. This was for revealing, so we need another function for hiding the enemy. We can just copy this and put it over here. Reveal enemy, change it to hide enemy. Let's keep this the same, and then this time we load the background palette and compare it to static value 11, and then instead of adding we need to subtract, and always set the carry before subtracting. SBC 10 and store it to background palette, then jump over this if we are in here, otherwise we have to put the number 11 there in hex and store it to back there. Then we are just increasing the loop, and then we have to make another phase where we hide the enemy. Let's make it 2. It's phase counter 2. We increased the boss timer and do the same trick as before to get 50 frames of time. Increase phase counter and reset the boss timer again. This is just to get some nice wait time there. We need 1 plus over here. And then in the next phase we are going to hide the enemy. This, and we jump to our subroutine we just made, hide enemy. We need to also load the background palette. Background palette +5. This is the palette 0, 1, 2, 3, 4, 5. It's this palette over there. We can just compare it, and need to compare it to 11 hex, and if it's not, we do nothing, and if it is, we increase the phase counter again. Alright, I had to pause the recording because there was a bug I couldn't find, but now I have found it, and it's another silly mistake I made. I forgot to put this loop label over there. Loop, and same in here, hide enemy, branch if not equal to loop. And now we can go and see what this game does. We should select the empty palette for now, because at the start we would like to hide every enemy. And let's press here and let's see what will happen. Okay, nothing at first, but if we put 0 to phase counter, we can see something happening over here. As this boss timer goes on, the enemy will fade in like this and disappear after a short period of time too. Okay, and then we need to do the same for all of the other enemies, and maybe we can add some randomization too during the process. So let's go to boss screen. Maybe we could do a little table first. Remember, this first enemy is phase number 1. So if we want to jump through the other phases, maybe it would be easier to make another lookup table for the phases. And the first one is phase number 1, and the next one is number 4 after this hide enemy. So the next one is 4, and the next one is 7, and the final enemy is 10. So now we have some place to jump to, and then it's just a matter of making this same logic over and over again. So I just pause the video for now and we'll be right back. Okay, now we have all the phases in there, and there's also one thing to do. You have to put these palette checks in hide enemy. The first enemy has the pal +5, the next one is pal +1, then it's pal +12 and pal +16. So now when we test this, we should see some other enemies also appearing on the screen. Here and here. And if we set this phase counter to 0, this is ready yet, set it to 0, you can see this. Okay, so when I was editing the video, I noticed that I made another mistake. When I was hiding the enemy, I have put the background pal variable over here. Instead we need to put the original background color variable here and then subtract from it. And another mistake I made was in this, after the face that hides the enemy, we have to check background pal +11 and +15, because they are the black colors in here, so we have to check against these. As you can see, it now fades a lot smoother than we had previously. Let's build a random generator. Let's call the function next random, because we are getting the next enemy over there. First of all, we have to jump to a subroutine called do get random number, and then we have to take away some bits. We only need four different random numbers, and we then transform it to y, load the phase counter, and we always have to set the carry when subtracting 2 from the phase counter, and then we compare it to phases which were here, the dedicated phase for each enemy, and if it's equal we do nothing, but if it's not we load phases y and store it to phase counter, and just remember to return from subroutine. So all this does, it takes a random number which is between 0 and 3, and then it converts it to these numbers over here. So, and let's go back to our phases over here. The spot where we would like to change the phase is this. So instead of just increasing the phase, we jump to our subroutine. We made called next random, and we do this for every other enemy too. From here 6, 7, it's here. And the last one over here. So now we should have quite random enemies appearing, as you can see. It's maybe too fast, I don't think, or it can't be too easy either. But yeah, this is pretty much everything I wanted to include in this second tutorial. There is not much of a game yet, because these enemies actually don't do anything. So in the next part of this tutorial we will be making some kind of collision checks between the enemy and the player, and eventually kill the player if he hits with some of the enemies. I hope you liked this tutorial, and if you like my stuff, what I'm making, please consider subscribing to my channel and giving a thumbs up for this video. And that's for it this time, and as always I hope you'll have fun making your own NES games too. Goodbye.